Hello? Yeah, you guys can hear me now. Good morning, everyone. My name is Sriram Krishnan. I work at the Big Data Platform team at Netflix. And today I'll be talking about Genie, which is our Hadoop platform as a service. So Netflix does Hadoop. This is not a huge surprise to most of you, probably. You've seen our tech blogs before. We use Hadoop in a variety of different ways. Netflix is extremely data-driven. You might have heard the story that when we did our first huge original series, House of Cards, it was an extremely data-driven decision. So basically, things we do with Hadoop matter, and people can actually see that. Netflix users can actually see that. We are running several hundred A/B tests at any point of time, so anytime a new feature is rolling out, we're actually testing that with basically our customers, and only if certain things test well, we actually roll it out in production. So we do Hadoop. Not a huge surprise to most of you. Why is this interesting? Because you probably knew this already. Everyone does Hadoop, actually. That's why they're here. So, well, we do Hadoop at scale. This is a nice little buzzword. Everyone uses scale, means different things to different people. So I should probably put an asterisk on it and tell you what scale means to us. So we log a ton of events. We log lots of events such as pause, play, rebuffers, things like that. So we're basically logging 80 to 100 billion events every day. So what that means is we're basically getting about tens of terabytes of data every day, compressed. That's the data we're ingesting into our system. On top of that, since we have retention, we don't store everything infinitely. Different data has different value. So we have different retentions for different data sources. So we're basically sitting on about 2 or so petabytes of data. So that's the scale we're talking about. And so people are processing this using Hadoop clusters on a daily basis. And every day, we're actually processing hundreds of terabytes of data on our Hadoop clusters. And what about the size of the clusters themselves? Depending on the time of the day, depending on the number of clusters we're running, we are looking at 2 to 2,500 nodes on a daily basis. So that's the scale we're talking about. It's not something to be laughed at, but there are probably other people with bigger Hadoop clusters. So again, why is this interesting to any of you, and why are we any different? So well, to that, I say we do Netflix in the cloud. We do Hadoop in the cloud at scale. So that's basically our distinguishing factor. So we're doing all of this. We're doing this 100% on a public cloud. So we're basically using AWS right now, which is basically our cloud of choice at this point. So we're running all our massive Hadoop jobs, several thousand nodes, few petabytes, everything in the cloud. And that's basically our distinguishing factor. And running Hadoop in the cloud is somewhat different from running Hadoop in the data center. So we've learned a lot of lessons along the way. And so we made some key architectural choices based on that. So we've written about this in the past, and today I'll talk to you about a couple of things. First, I'll start with basically the general architecture, what it means to run Hadoop in the cloud, and how we run it at scale. And also talk about one key piece that we open sourced recently called Genie. So to start with, basics first. We're running Hadoop in the cloud. Our data is extremely valuable to us. So where do we store the data? So typically, if you're running Hadoop in your data center and you're storing all the data in Hadoop, you're typically storing it in HDFS. HDFS has a lot of cool things. You get data locality. There is triple replication, all that kind of stuff. So we don't. In the cloud, we basically choose to keep all our data on S3. Why do we do that? Because S3 provides a lot of benefits. One of the main reasons, it's highly durable and highly available. So basically, there's 11 nines of durability is what Amazon claims, so which is actually pretty useful for us because we treat our data is really precious to us. The other thing it provides bucket versioning. So if you ever delete a file, you can always go back to an old version. And one other thing is since we think of ourselves as a growing business, it is super elastic. So basically, our Hadoop data warehouse has grown organically over the last year. So it's about a couple of petabytes now. If you ask us 6 months later, it might be completely different. In fact, it's practically doubled over the last year. So it's basically, that is super, super useful for us. Now, having said that, not everything is awesome. Because a couple of benefits of using HDFS, like I mentioned before, is data locality. So you lose some of that with S3. So you are taking a little bit of a performance hit. But for us, for the benefit it gives us, the performance impact of running against S3 is not that significant that it is proven to be a deterrent. And I can talk a little bit more about details if you want after the talk, or you can come talk to us at the booth. But basically, S3 provides us a lot of benefits, and we've chosen to put all data in S3. One of the other key benefits that S3 provides is we can run multiple Hadoop clusters that are basically pointing to the exact same data source. And that is super useful because in the cloud, Hadoop clusters are at least expected to be transient. So if we lose a cluster, we don't want to fret about it. We basically, all we would do is we would spin up another cluster to replace it. And if we had all our data in HDFS, you could, of course, not do that. But basically, we have multiple Hadoop clusters based on the type of workloads they support, all pointing to the same source of truth, so to speak. Basically, we treat our clusters almost interchangeably, and their existence is only because of the different types of workloads they support. So we run multiple Hadoop clusters. To give you a sense, we have a fairly large production SLA cluster, which is about 800 nodes or so. We have an ad hoc cluster where people are running all sorts of crazy algorithms and such. That's about 1,200 nodes. We also spin up nightly what we call bonus clusters. So one of the cool things is a lot of the ETL that we run actually happens to trigger around midnight. And just because of the nature of the viewing pattern of basically North America, people are watching less movies at night. So we have a surplus of cloud instances. So what we do is we just spin up another Hadoop cluster to augment our ETL processing. And again, that hits the exact same data source. So basically, we have clusters that are pointing to the same data source, and we don't have to do any kind of synchronous replication or anything like that between these clusters for them to access the same data. So those are the couple of key tenets of our architecture, is basically the separation of compute and data resources and the use of S3 as our source of truth. Another thing we've done, which is a lot of the value that our team, or the big data platform team at Netflix brings in, is we're trying to abstract all the transients and everything at the bottom from our end users. So as a team, our goal is to provide a platform for the rest of Netflix to run Hadoop jobs. So what we've done is we basically built a Hadoop platform as a service. So one of the things it basically abstracts out all the various cluster configurations at the back. And what users can do is they can use a REST API to submit a job. So as a user, really all you care about is you have a Hive script or a Pig script, and all you want to do is run it, right? So you shouldn't really have to worry about the different manifestations or incarnations of the clusters that are spun daily. So what we do is we have an API that we built on top of it, which provides Hadoop platform as a service. And in fact, we take this a step further. We have many such services. We have a metadata service, which we call Franklin, which we will talk about tomorrow during another talk that we're doing as well. And finally, there are all these APIs. But even that is actually, that abstraction is still not sufficient for most of our users. Very few people, basically only engineers are going to use our API and run the jobs. Most of the people tend to use higher level clients even on top of that. So we have a set of tools that we built on top of the API, and that's what the API opens up for us. For instance, we use a tool called UC4 for our workflows, which basically manages a set of hybrid ETL processing. By hybrid, I mean there are some Hadoop jobs. We also happen to run a fairly massive Teradata installation. So basically, it runs a bunch of Hadoop jobs that run aggregates, stage it into Teradata, run Teradata jobs, and so on. We have this process called Ursula, which is basically responsible for processing those billions of log events that I talked about and making it accessible through a Hive metastore. We have Igathis, which is basically our pipeline from our dimension data, which is Cassandra-backed, into our cloud warehouse. And we have a set of other utility tools. Forklift is a tool which forklifts data essentially from one source and puts it in another, the sources being S3, Hadoop, Teradata, basic files, things like that. Sting is this very cool tool that we built, which basically provides kind of OLAP-style visualization, where you can slice and dice your data, which basically hits Genie, runs queries, caches data, and you can do various ags on it. And we'll be demoing some of that as well in our booth if you stop by. Looper is another tool that basically does the same queries over and over again for backfills and things like that. And this crazy pig that you see here is something that we open sourced as of basically 10 a.m. today, which is a pig visualization tool called Lipstick. So I encourage you guys to check it out, and I'll provide you some links that help you do that. So for the rest of the talk, I'm just going to focus on that Hadoop platform as a service layer, which we call Genie. So why Genie? Why did we build this? For two reasons, mainly. We want to provide a simple API for job submission and management. So the Hadoop community thus far, mostly really because it's really early days in the Hadoop world, Usability has not been one of the key focus points, essentially. So if you want to run a Hadoop job, you basically have to get all the clients, get all the config files that you need to talk to Hadoop itself. Why not just build a simple API where users can submit their scripts to run, all the dependencies, and basically just magically runs it for you? So that's very simplistic. That's the simplistic model that we as a platform want to provide to our users. So this is equally applicable throughout the Hadoop ecosystem, whether you're running it in the cloud or whether you're running it in the data center. An API actually is super useful. Another thing which is a little more applicable really mostly to the cloud is that we wanted to provide an abstraction for the back-end details of the Hadoop cluster. Since we have multiple clusters spinning up and down at different times, we want to just abstract that out from Hadoop, from our users. So we wanted an abstraction layer that does that. So how about some other tools in the space? So one of the obvious comparisons would be Amazon's Elastic MapReduce. EMR provides an API to run Hadoop, what they call job flows, which are essentially clusters. And then you can chain a set of jobs through using EMR steps. So how is this any different than that? Basically, think of it as one level of abstraction higher than that. So that provides you an API to submit jobs. But if you were, as a team, to manage a cluster for a set of users, then actually, in reality, we ourselves use EMR to launch those clusters. But this is an API on top of that, which aggregates a set of clusters for users to use. So it's a slightly higher level of abstraction. Another comparison that comes up a lot is, how is this different from Oozie? And one main difference is that Oozie schedules workflows, Genie schedules jobs. It's a different grain. It's a different level of granularity. So what Genie is not, it's not a workflow scheduler, such as Oozie. The unit of execution is a single job. It's not a task scheduler, such as a fair share or capacity scheduler. In fact, at Netflix, we use fair share scheduler on most of our clusters. And finally, it is not an end-to-end resource management tool. And what I mean by that is, Genie is not going to provide an API for you to create a new cluster in the cloud. All it's doing is, once you've created a cluster, it basically lets you manage its lifecycle and also route jobs to it, and through a REST API. In fact, we like to call Genie a matchmaker because it basically matches jobs to resources. So the two services that Genie provides, it basically provides job execution. So it's a simple RESTful API to run Hadoop Hive-and-Pick jobs. And it does this automatic submission of jobs to the right Hadoop cluster. And it also abstracts away the cluster details from our clients. And the second is a resource configuration service, which is equally important, which is basically an API for the management of cluster metadata. So it can basically say, you have a cluster, my cluster is up, and my cluster is out of service, or my cluster is terminated. Only if it is up, it is actually ready to accept jobs. And it also has all the various configuration files. So if you're familiar with Hadoop administration, it's basically the core side, HDFS side, MapReduce side, XML, things like that are needed to actually talk to a live Hadoop cluster. So for every cluster, Genie has that metadata. It also has metadata about the different metastores that it supports, which basically map to the Hive side.xmls for a particular cluster. And also has additional metadata. Like, for instance, you can say, I have this cluster which runs SLA jobs, or I have this cluster that runs ad hoc jobs. And Genie, based on that, will route jobs to that particular cluster. So how does this all work? It's basically built on top of the Netflix OSS stack. If you're not familiar with the Netflix OSS stack, I encourage you to go to our GitHub page, and you'll find a lot of cool tools for you to use. It basically it's built on top of the Netflix base server, which has been open sourced as Carrion. And it uses a key service that Netflix has built called Eureka, which is basically a discovery service. So we run a fleet of Genie instances. It's not just one instance. So when an instance comes up, it'll register itself with Discovery or Eureka. And now you have a bunch of instances that you can load balance across. It also is built on top of Archaeus, which provides dynamic property management, which you can essentially change your properties on the fly. And so it is aimed at two classes of users. There are the admins, and there are the end users. So in our world, I mean, since we are the platform team, we basically span the first two sections, which is the cluster admins and Genie itself. And everyone else at Netflix who uses it basically is an end user. So what happens? You can actually build a WAR file, deploy Genie into Tomcat, and then it's actually not super useful yet. So you have to do something to actually make it useful. And what is that? Basically, what happens is we have a bunch of cluster admins who would spin up a new cluster as and when it's needed. And then after you spin up a cluster, they'll discover a Genie instance through this discovery service. So there'll be one of many to choose from, and it'll just pick one. And then after that, they'll basically say, I have a new cluster. This is the configuration of this cluster. I'm just going to register it now with Genie. So for instance, we have one prod cluster that supports SLA workloads. We have one ad hoc cluster that supports ad hoc workloads. We have a test SLA cluster where we support some testing for some of the things we want to promote to production. So you can tag your clusters in various ways, and you register that with Genie. And finally, as a user who doesn't care about anything that's happening at the back, what you would do is you would use a Java client to discover a Genie instance, one of the many, and you would pick an instance. Actually, the client abstraction abstracts it all for you. So, but basically, internally, what's happening is an instance gets picked, a REST call gets made to an actual instance, and then Genie finally ends up launching a job on behalf of the user. So now, this is completely abstracted out from an end user's perspective. So how it works, a client makes a REST call, which provides parameters. So the joke inside Netflix is Genie grants wishes, except it can only grant 3 wishes. You can run a Hive job, you can run a Hadoop job, or you can run a pig job. That's it. So in this case, you specify a job type. You specify file dependencies, scripts, and things like that you want to run. Command line arguments, the type of, whether it's an ad hoc job, whether it's an SLA job. And you also say that this is the configuration is an alias for a metastore. So it's a prod metastore or a test metastore. And it's an asynchronous call. Genie returns back job ID, which you can use to query for job status, get outputs, kill job, and things like that. One of the cool things that you basically get an output URL, which kind of looks like this. So in this case, basically what we do is we make it accessible via the web container. So the working directory is accessible through your web browser, essentially, of your job. So a new job ID gets created. The file dependencies that a job has get staged to the working directory. And then you can actually see the standard error and the standard out logs as the job is running. So if anything is wrong, you can actually debug it, which is proven fairly useful. One other thing it does, it runs each job as a separate process. So there's actually isolation between jobs and between the jobs and Genie itself. So each of the jobs are actually running in a separate working directory in its own environment. So the flip side to this is basically every job basically spawns a new JVM, which basically means that it needs memory, which means you can only run a finite number of instances, finite number of jobs on each Genie instance. And we work around that by scaling horizontally. So you can have many instances that are supporting jobs at any point of time. So how is Genie used at Netflix? How are we actually using this to enable all our various use cases? Some of the things we've talked about and also written about, we actually run these nightly short-lived bonus clusters to augment our ETL processing. We reroute traffic between clusters as and when they're ready to accept new jobs. We do what's called a red-black push for a cluster, which is basically our solution to not doing a rolling upgrade, and I'll actually talk about each of these in a little more detail. You can attach standalone gateways. So a lot of times what happens in a typical Hadoop world is you have this machine where everyone is running your Hadoop jobs on, and that actually becomes a point of contention or a single point of failure. Because again, a Hive job or a pig job is a separate JVM, and it basically blows up on people. So essentially, we have a concept of a personal gateway, and all it does, it goes to Genie, fetches the latest configurations, and now it can talk to that specific cluster directly. And people are actually using this interactively using the pig and Hive clients. So Genie runs essentially 100% of all our SLA jobs, essentially all our ETL jobs at Netflix, and a fairly high percentage of our ad hoc jobs also. And I'll give you some scale numbers. I have some graphs later to show. So let me talk about bonus clusters first. So this is so consider the scenario where you have a prod SLA cluster, which is all fine. This is our steady state. It's accepting jobs. But now every night, like I mentioned, we have a surplus of instances because we have our cloud instances for the cloud services have scaled down. But we also have this ETL processing to do. So what we do is we spin up a new bonus cluster. And now all these ETL jobs are basically going to look for this bonus cluster. If they find it, they'll actually go ahead, Genie will actually go ahead and submit jobs to that cluster. If the cluster is for some reason not instantiated, it'll go back to the production cluster. So what happens also is, say around 6 a.m. or so, when we need to give all those instances back, we mark this bonus cluster as out of service, which basically means it no longer accepts any more new jobs, but it'll let all the jobs that are running on it finish. And once it's finished, essentially we take it out. And so every day we were actually spinning 2 or 3 bonus clusters, and this is completely automated. No one, once we wrote the scripts to do this, it was all, it all just works. So that's one of the use cases. Another is rerouting traffic between clusters. So let's say we have this prod cluster that's supporting prod traffic, and then we have to make some change to some configuration. So sometimes, to give you an example, let's say that we want to enable priorities on our scheduler, which we had to do at some point. So it requires a bounce of the job tracker. So if you want to do this with no impact to the users, then you cannot do that if you basically just had one cluster. So what we actually did in this case was we temporarily marked this ad hoc cluster as an SLA cluster. So in the interim, all jobs were routed to that. We marked the prod cluster as SLA cluster as out of service. We did whatever we had to do, marked it back as up. All jobs were rerouted back to the original cluster. We don't do this very often. What we actually do is red-black pushes. So every time you want to upgrade anything on your Hadoop cluster, typically what people do is they do rolling pushes. So you basically upgrade all your instances one at a time. And finally, you have to upgrade your name node and job tracker, and then you have to basically bounce it or some such. So what we do, since the beauty of the cloud is you can actually run any number of clusters at any time, so what we do is we just spin up a new cluster with the completely new stack. We mark that as up, mark the old cluster as out of service, wait for the jobs to finish, and then take it out. So it's basically just a few clicks. It's incredibly simple. We've basically not done one rolling push for about a year or so that Genie's been around since we rolled it out. So how is Genie used at Netflix? So you can actually see that it's used pretty heavily. You can, in this, we actually show you the total number of Genie jobs that have been running on a couple of different clusters. So if you read our blog that came out recently, we actually showed the total number of Hadoop jobs that are running. And the correlation here is that a Genie job can map into multiple Hadoop jobs, because if it's a big job, it's a multi-stage job, and you have multiple Hadoop jobs. But in terms of scale, Genie's running close to 4,000 to 6,000 jobs, basically production jobs, on our SLA clusters. And similarly, we have a fewer number of ad hoc jobs, because a lot of our ad hoc users still want to be a little more interactive. But it's mostly used for all programmatic access to our clusters right now. So one interesting tidbit here as part of this graph here is that you can actually see 2 ad hoc clusters. And what we did over here was we wanted to roll out a new version of the fair share scheduler. And at Netflix, we A/B test everything. So we A/B tested this as well. So we had a new feature we wanted to roll out. So we created a new ad hoc 2 cluster with the new fair share scheduler. We let Genie route jobs automatically between one of these 2 clusters. Both of them served as ad hoc clusters. We checked to see what the impact was, made sure that everything was OK. And once everything was OK, we spun up a larger cluster that took care of basically all the, that basically consolidated both the clusters, and we went with that. And all the jobs that were running in the previous clusters, we let it terminate, and that was the end of that. So essentially, Genie, if there are multiple clusters to run jobs on, Genie will automatically pick one of them, and right now it is at random, but it's a pluggable interface that one can actually write whatever, basically based on load, you could actually potentially write a better scheduler for it. So the usage statistics, the graph that you see here is brought to you by a tool that we codenamed Sherlock. Why Sherlock? Because it's basically an investigative tool. We are going to write a tech blog about this soon, but it uses a pig job to gather the statistics for all the running jobs and populates it in a database, and we use Tableau for the visualization. So the graphs are actually built using Tableau. So stay tuned for that. How is Genie deployed at Netflix? So as I mentioned to you, Genie can run a finite number of jobs on a particular instance. So, but it is still running hundreds of concurrent jobs at any time. So we do that using auto-scaling groups in the cloud. So there is actually a fleet of instances. So in this case, we use this tool called Asgard. So you can actually, I'm going to walk here to point at a few things. So you can actually see here that it is running in multiple availability zones. So within each region, there are different availability zones, and it's running in multiple for essentially fault tolerance. If one of the zones goes down, Genie's still up and handling requests. You can also set a total number of instances. So in this case, we actually said, give me anywhere between 4 to 12 instances. My desired number of instances is 8. And so depending on the load, we basically want to scale up if needed. And also, this tool provides you a method to manage upgrades. So if you had a new version of Genie to push, we do a similar concept of the red-black push that I talked about before. You spin up a new ASG with the whole new stack, and you just route traffic to it. And that is basically something we do all the time, every week, pretty much. What this tool is it's called Asgard, and it's also part of the Netflix OSS stack. And it is actually a heavily used tool, and you can use it if you want to run any cloud deployments, whether it be Genie or otherwise. So if you had your own set of services that you want to run in the cloud, and you want to maintain auto-scaling groups, and Asgard is a tool that I would encourage you to check out. So one other final thing I wanted to mention about that is you can also set up auto-scaling policies using Asgard. So in this case, we actually set one up to actually say, if the total number of running jobs on a particular instance, in this case is, let's say, greater than 25, just as an example, then spin up another node. So this actually says change in capacity 1. So it increases the number of nodes by 1 if the number of running jobs is basically greater than a particular threshold that we set. So that helps us account for spikes in load, which typically happens when someone at Netflix is DDoSing Genie, essentially. So I'm happy to announce, and we actually announced already through our tech blog, that Genie is now open source. So if you haven't looked at it before, I encourage you to check out our tech blog, which talks about Genie in a little more detail. You can clone Genie at GitHub. This is still pretty much version 0, but it's practically the same code that runs in production at Netflix. So we would welcome it if you would check it out. Any kind of contributions and feedback is welcome. One other thing that Netflix is actually running right now is the cloud prize. So if you had some awesome contributions back, maybe you could also win something. So that would be pretty cool for both of us, I guess. We are also doing live demos and such, so you can come check out Netflix at the Netflix booth, so you can talk to the engineers who built this. But we're looking for feedback, and essentially contributions, comments, everything is welcome. One other thing I wanted to mention to you is a plug for a talk we're doing tomorrow. It is called Watching Pigs Fly with the Netflix Hadoop toolkit. And this is a tool that we're going to showcase is called Lipstick, which is a pig visualizer, which lets you visualize running pig jobs, essentially pig jobs as they're running. And we're also going to talk about the rest of the Netflix data platform as a service. So it's one level of abstraction higher than the talk I just did right now. So please check it out. And also, that is open source as well as of today. So I think that's really all I have. I just wanted to thank you for your time. We are hiring. I think everyone here is hiring, but hopefully I've piqued your interest a little bit that you actually want to come work for us or work with us. So thank you. I can take questions now if you have any.
I had a question.
Yes.
You guys are probably using S3 or EBS as your storage across your various applications, correct?
Yes.
Given that a lot of that clearly is remote and not local on the nodes, so there's a big performance hit. So how does that affect you, and are there special things that AWS is doing so that if you are running a particular one of these transient clusters for long, AWS does a better job of not just always pulling it from S3 or EBS?
So we use S3. We don't use EBS at all. So we're actually not running our Hadoop. Basically, we're not using EBS to host HDFS. S3 is our source of truth. And you're right in the sense that there is a little bit of a performance hit. So I alluded to that a little bit during my presentation. But we use EMR. So full disclosure is we've done some benchmarkings, but they're all on EMR. So we've done some performance benchmarking of essentially some of our queries reading data from S3 versus reading data on HDFS. And they're actually remarkably close. So one thing we do is, one thing to make very clear is when we spin up new clusters, we're not seeding our cluster. So we're not fetching all the data from S3 and putting it back into HDFS. Basically, if you have a multi-stage MapReduce job or a pig job or whatever, the first stage, all the mappers are going to go to S3 in parallel and fetch the data. And then your last stage, if you have reducers, they're going to write back data to S3. So if you have extremely read-heavy workloads, then you would actually see the impact of that performance much more. But if you have multi-stage jobs, that cost basically gets amortized. So it is indeed a performance hit. But writes to S3, we've actually found are actually faster than writing to HDFS in the cloud. So it's almost a your mileage may vary kind of thing, but we've actually done some performance benefits, performance benchmarking, and in our experience, it has not proven to be bad enough to basically outweigh everything else that this provides, which is basically the fact that you can run any cluster whenever you want, point it back to the same cluster, same data source and such.
Hi, so the question is, how do you manage the cost when you auto scale up and down? I mean, I'm especially interested in how many percentage of your nodes are scaling up and down every night or day or something like that.
So yeah, that's a good question. So we've actually talked in the past that we actually scale our clusters up and down, and we have done that before. But what I was talking here mostly was we are actually spinning up new clusters. So they're not scaling an existing Hadoop cluster. They're basically spinning up a new Hadoop cluster. And then all it does, it registers itself with Genie. And Genie now knows about it, and it can actually schedule a job on it. So in terms of numbers, if our prod cluster is, let's say, 1,000 nodes, this would be a 300-node addition every night, or maybe a 400-node addition. That's basically the ballpark we're talking about. We have, so the reason we do, so there's also the reason we do that as opposed to just scaling up and down all the time is because the instance types of these new nodes that we get are actually different from our regular instance types. So we run M1X large nodes for all of our regular Hadoop clusters, but we sometimes use M22X large because that's what the rest of engineering uses, and that's what we have excess capacity for. And mixing and matching instance types doesn't really work that well. So we actually end up spinning up new instances that works much better.
Okay, thanks.
I think you actually answered most of my question, but so I was going to ask about the instant types, and specifically, with S3 instead of HDFS, I was assuming you guys were using the instant types that had the 10 GBE type cards, but it sounds like you're not. Have you compared like the cluster computer, the high storage? Is it more of a cost thing with your extra large, or?
So yeah, basically everything that comes out, we test and we benchmark to make sure that, is it any better or worse? So yeah, so CC2 instances have better interconnect, obviously, but yes, it is a little bit of a cost thing because what we're trying to see is whether a 4x increase is gonna, or 1/4 the CC2, 1/4 the number of nodes of a CC2 is gonna give you the same performance as, let's say, 4 or whatever the factor is, or 1/3 or whatever, right? So it is a cost thing. So we basically want to get the same bang for the buck. So for the most part, we've benchmarked it, but we haven't really used CC2 on any of our production instances. In many ways, actually having a large number of nodes that hit S3, you get better bandwidth because you have more nodes in parallel hitting S3.
Okay, thank you.
Yep.
Hello, a very similar question, on this side, thank you. Can you say something about the scheduling part when you have a new job coming in and you have a couple of the candidates? Because the cost for each Amazon EC2 cluster is different, right? Also consider the network and the storage side. But I didn't hear you mention anything about scheduler. So is that kind of first in, first out, or you have some smart thing able to share? Thank you.
So how do we schedule our jobs is basically the summary of that question. And it's basically a 2-level hierarchy. So our Hadoop clusters themselves use fair share scheduler. So it is not first in, first out. It basically uses fair share. Now, as far as Genie is concerned, Genie is, by design, we made it extremely simple. As and when it gets requests, it just submits it. It just finds a cluster. It basically does resource matchmaking, like I said, finds a cluster to run a job on, and just submits it instantly. So Genie doesn't have a queue of jobs, basically, and we didn't want to do that because if we did, then we would have to reinvent the fair share scheduler or something like that for Genie itself. So all it does, it submits jobs, and then the individual fair share schedulers or capacity schedulers or whatever we have running on the nodes, on the clusters themselves are responsible for scheduling. So on top of that, what we do is we use the fair share scheduler in however ways whatever ways it provides, and we also we improved it a little bit. So we have high priority pools for our higher priority jobs. We have minimum and maximum share for jobs and things like that. So we basically tweak, we use pretty much all the hooks that the fair share scheduler provides.
Okay, I see. Thank you.
For your production clusters, how often do you tear them down and re-provisioning? And typically, how much HDFS do you use for the local HDFS?
We actually, every time we test a new feature, so Netflix is like extremely agile. So if someone in our group tweaked the fair share schedule a little bit, we wanted to push it out. So we pushed it out. I mean, and we basically did a red-black push for it. So let's say on an average, so these clusters we consider semi-persistent. They're not persistent, but they're not super short-running either. But if we lose them, we don't care. We just spin up another one. So for all practical purposes, that's nothing important except transient data that's on HDFS. Transient intermediate data is indeed on HDFS. That's basically results of intermediate results between jobs. But all our crown jewels, so to speak, are on S3.
Thank you.
OK, I think I have time for one more question. And I think I can also answer most of them offline.
So when you guys spin up a new cluster, the data movement between the to the new cluster, how does it happen and how long it takes and what is the volume of the data that we are talking about here?
0. Basically because there is no data movement between clusters. And the reason for that is because, like I said, when we spin up clusters, we don't seed our clusters. So all our data is still always on S3. And that's only used, so when a new job comes in that wants to read, let's say, 30 days of this particular Hive table, then it basically gets picked up on the fly as needed. So when you spin up a new cluster, it's actually clean. There is actually nothing in it. When people start running jobs, basically intermediate results end up going to that cluster. And one of the reasons we can do this is because of the fact that we've decoupled our computational from the storage resources. So I think that's all I have time for. Thanks a lot. And I can answer more questions offline if you have. Thank you.